So note that the Fourier transform of a function f of t from our previous discussion is given by the integral from minus infinity to positive infinity, the function f of t multiplied by e raised to power negative I omega t dt. And even before we do some specific example on how to compute the Fourier transform, you recall that Laplace transform of a function f of t was given by f of s. The integral was from the lower limit, value was what the lower limit in terms of the Laplace transform?
0.
0, and then the upper limit infinity, e raised power negative s t dt. So you can see some resemblance in the structure. The only variation is that in the Fourier transform, the limits are from minus infinity to positive infinity, but for the Laplace transform, 0 to infinity. Both of them are improper integrals because at least you can see one of the limits of integration is infinity. And then the structure here, the function f of t in both transforms occupy the same position. And this kernel, the only variation is that in the case of the Fourier transform, instead of having s, we have the factor I omega. So which means that if you change the lower limit of the Laplace transform to minus infinity, and in the kernel, instead of having s, you put I times omega, where I is the complex unit, you get the structure of the Fourier transform expression. And later on, you'll be able to see that there's a formula that actually gives the relationship between the Laplace transform and the Fourier transform of a function. So let's do the first appetizer to appreciate how to find the Fourier transform. So appetizer 1. Find the Fourier transform of a function f of t given by u of t times e raised to power negative t, where u is a unit step function. So this is the first appetizer problem, to find the Fourier transform of this function given by the unit step function times e raised to power negative t. If you are serious enough, you know what a unit step function is, either from other engineering course or from your study on Laplace transform. So recall that the unit step function is defined as 1 when t is positive and 0 otherwise. So that's how we define the unit step function u. So we have the function f of t. We know the formula for the Fourier transform of a general function f of t. So it will not be very hard for us to compute the Fourier transform since we have the f of t and we also know the definition of the Fourier transform. So every solution comes from the definition of what we are defining. So the solution will be, we know that the Fourier transform of f of t is given by the Fourier transform of the function f of t is f of omega, which is the integral from minus infinity to positive infinity, f of t multiplied by e raised power negative I omega t dt. This by definition. And you can't get the solution without knowing that definition of the Fourier transform. And the interesting thing is that we know the f of t, which is given by u of t times e raised power negative t. So this will be the Fourier transform from minus infinity to positive infinity. So where this f of t replaced by u of t times e raised power negative t times this kernel so that is giving sense to the formula with the value of the function that we have. Now we can actually see what this u function is. So if I may draw a line here, so this way you have minus infinity, this way you have positive infinity. So this is the real line, and say this way you have 0. Now from the definition of the Fourier transform, we expect to carry out our integration from this point minus infinity to this point positive infinity. But the nature of our f of t, we have the unit step function whose value is always 1 whenever t is more than 0, but other values of t, the value of the function is 0. So which means that on this line, from 0 to infinity, u is 1, but 0 to negative infinity, the value of u is 0. So that means that if my f of t is given by u times e raised power negative t, then I'll have 0 times e raised power negative t, which is 0, whenever my t value is from minus infinity to 0, because the value of the unit step is 0 in that interval. But the f of t will be u times t e raised power minus t. So from 0 to infinity, the value of u is 1. So I'll have e raised power minus t whenever my t is from 0 to infinity. And from our calculus class, we know that for us to carry out integration from minus infinity to positive infinity is as good as carrying out integration of the same function from minus infinity to 0 and then summing to integration of the same function from 0 to infinity. And because from minus infinity to 0, f of t will be 0. When we carry out the integration in that interval, we get 0. So it will be of no use from minus infinity to 0. So we only concentrate from 0 to infinity because that is where the f of t is going to give us a non-zero value. So therefore now, instead of having to integrate from minus infinity to infinity, we are going to integrate from 0 to infinity. Reason being, from minus infinity to 0, the f of t is 0, and when you carry out the integration is 0, so it doesn't add any value to the integration problem. So the Fourier transform of u of t e raised power minus t will be f of omega. So instead of moving from minus infinity to infinity, I move from 0 to infinity, and u is 1 multiplied by e raised power negative t times e raised power the negative I omega t dt. Since you can actually give that reason, since f of t is 0 for all values of t less than 0. And if you remember the way we were computing the transforms in the case of Laplace transform, because we are dealing with an improper integral, and we expect to get a limit for us to get the exact value of the integration, we rewrite the function in such a way that final answer in the derivative in the integral will have an exponential which is in the denominator that can allow us to get the limit in a much easier way. So that means we'll rewrite this as f of omega will be the integral from 0 to infinity. So I put e raised power negative, then t plus I omega t dt. So remember, I'm just applying laws of indices, which can be rewritten as 0 to infinity e raised power negative 1 plus I omega t dt. So I'm writing that so that I can easily use substitution method to carry out the integral. And this integral will give or the integration of e power minus 1 plus I omega t. Use U substitution. What value do you get? E power negative 1 plus I omega t divided by which value? Don't disappoint your calculus teacher. So we divide that by negative of the 1 plus
yeah
I omega, okay?
omega.
Do you have that? Do you
Yes.
agree with that, Andra? Yeah. So note that what is doing just now, the key problem was to integrate e my 1 plus I omega t dt. So it lets u to be negative 1 plus I omega t. So du will give you negative 1 plus I omega dt. So which means dt will be du over negative of 1 plus I omega. So this will give you now e raised power u times dt is the same as du over negative 1 plus I omega. And you can factor out this because it doesn't have a u. So negative 1 over 1 plus I omega integral of e power u du. And when you integrate exponential u, you get exponential u. So e power u over negative 1 plus 1 I omega. So this is why we are getting the solution here. So which can as well be written as a negative 1 plus I omega into 1 over e power 1 plus I omega t. T from 0 to t equals to infinity. So when t is a very large number, what happens to the quotient 1 over e power 1 plus I omega t? When t is large, the power becomes so when t is large, what happens to the power of e?
It becomes larger.
It also becomes large. And then so e power a large number will also give a large number. 1 over a very big number.
It approaches 0.
Approaches 0, correct. So the upper limit will be 0. And then minus. When you put t for 0, the power of e will be
1.
So it will be 0 and then e power 0 is 1. So 1 over 1 is 1. So opening the brackets, negative and negative cancels out, so that f of omega will be nothing but 1 over 1 plus I omega. So that's what we get for that given problem. That the Fourier transform of u of t e raised power minus t is nothing but 1 over 1 plus I omega. So problem 2 or appetizer 2 so use Fourier transform pair to find the Fourier integral representation of the function defined by f of t is 1 whenever t is between minus 1 and 1 and 0 otherwise. So remember, when I write absolute of t greater than 1, I simply mean that the value of the function f of t will be 0, provided that the value of t is not anywhere between -1 and +1. Can we now solve the problem?
Yes.
So just remember the two formulas given in the question 1 and 2. So note that f of t, which is actually the inverse Fourier transform of f of omega, is given by 1/2 pi integral from -infinity to +infinity f of omega e power I omega t d omega, and f of omega is given by, or which simply define the Fourier transform of f of t integral from -infinity to +infinity of f of t e raised power minus I omega t dt. This by definition of what you mean by Fourier transform pair. So what the question is asking us is to rewrite this f of t in this form involving the integral and this coefficient 1/2 pi, where the transform is given by this integral. So the work will be to find f of omega. Once we get f of omega, then we come and replace it here. So by doing that, we will have expressed, or we have found, the Fourier integral representation of the given function f of t. So f of t, or f of omega, is given by the integral from -infinity to +infinity of f of t, and then e raised power negative I omega t dt. But we have the definition of the function f of t, as different formulas on different domains of the function. That if you have, for example, this is a real line from minus infinity to positive infinity. So say there's 1 here, there's minus 1 here. So anywhere from minus 1 to 1, the value of the function is 1. But anywhere outside the interval minus 1 to 1, the value of the function is 0. So if, by definition, we have to carry out integration from minus infinity to positive infinity, then using properties of integrals from calculus, it is the same as carrying out the integration from minus infinity to minus 1, then plus integration from minus 1 to 1, and then finally integration from 1 to infinity. But we don't have to struggle to carry out the integrals from minus infinity to minus 1 and 1 to infinity, because the value of the function is 0. So when we multiply that 0 by the kernel e raised power minus I omega t, the integrand becomes 0. So the value of the integral will be 0. So the only part we concentrate on is this part where f of t is not 0. So instead of carrying out all this integration, it's as good as saying integral from minus infinity to minus 1 of f of t e raised power minus I omega t dt plus from minus 1 to 1 f of t e raised power minus I omega dt plus from 1 to infinity f of t e raised power minus I omega t dt. That's from calculus. We can close our eyes and say this is 0, and then this is 0, since here f of t is 0, and f of t here is also 0. So this is the only part that remains, because the value of the function from minus 1 to 1 is 1. So that will mean f of omega is integral from minus 1 to 1. F of t is 1, e raised power negative I omega t dt. So which is nothing but from minus 1 to 1, e power minus I omega t dt. And what is the value of that integral? When you integrate e raised power minus I omega t dt, so I use integration by u substitution. Don't disappoint your calculus teacher. There we get. Wangoi, what's the answer from your end? Kara?
E
Okay.
raised power negative I omega
T.
omega t over
Omega.
negative I omega.
Correct.
Yeah.
So we can always factor out the minus 1 over I omega. So upper limit, when you put 1, we'll have e raised power minus I omega minus e raised power. What will be my power? Where they stay, I put negative 1. What will be the power of e?
Positive.
Positive now, I omega, okay? Also we'll be having negative I omega times negative 1. So remember, we are replacing the limits are for t. So negative and negative cancels out. So I can multiply through by negative. So I have 1 over I omega into e raised power I omega minus e raised power minus I omega. Are you convinced that that's the correct statement after multiplying by negative 1? Do you agree with that new expression?
Yes.
Yeah, but we know from your pure math in first year, but by Euler's relation, we know that e raised power I theta is cosine theta plus I sin theta, and e raised power negative I theta is given by those who are still revising their first year notes. A power negative I theta. Cos of theta minus I sin theta. If I subtract these two, I get e power I theta minus e power minus I theta equals to I'm subtracting top down. 2I sin theta. So which means that the expression e I omega minus e minus I omega is nothing but
I sin omega.
2I sine of omega, okay? So 2I sine of omega. So you will replace this value in this formula for f of omega, so that f of omega will be 1 over I omega times 2I sine of omega. What does that simplify to? So when you simplify that, you get
2 sine omega over omega.
correct. 2 sine omega over omega. So that's the value of the Fourier transform. So therefore, f of t is the same as 1 over 2 pi integral from minus infinity, positive infinity. And the place of f of omega, you put 2 sine of omega over omega e power I omega t d omega. So this is the final answer. So that is the function given in integral representation or in the Fourier integral representation. Is the required integral representation. So I usually know the strength of my class, and I'm convinced that those two examples or those two appetizers are enough to expose you to as many problems as you can on how to solve the Fourier transform or how you can transform a given function in integral Fourier transform representation. So if you might remember our discussion on Laplace transform, once we defined a Laplace transform of a function, and we did examples on Laplace transform, the next section was to discuss, after the examples on Laplace transform, what was the next section?
Inverse.
Okay, so before inverse, there's something that we discussed.
What is?
Before the inverse, there was also something that we discussed.
Derivative.
Before derivatives, there's something we discussed. And I believe I gave us an exercise. Correct. Properties of Laplace transforms.
Find value
So it's the
theorem.
same. So it's the same structure that we also take for this given topic. Once we have defined the Fourier transform, we have done examples on Fourier transform. So the next thing is to discuss the properties of Fourier transform operator. So properties of the Fourier transform. And by the way, we have always been friends for the last 3 years, and probably you have predicted my style of teaching and testing. So probably you know that when I say this is an exercise, that is usually the most part that I concentrate on when I'm setting cuts and assignments and final exam. So for those who are lucky to do the exercise on properties of Laplace transform, what are some of the properties that you were able to discuss? Properties of Laplace transform.
The linearity property.
Linearity property, correct. Any other property? Apart from linearity?
The shift theorems.
The shift theorems, correct. So the same way those properties were coming out on Laplace transform is exactly the same way the properties of Fourier transform also are coming. So we discussed the linearity property of a Fourier transform and also the shift theorems or shift properties. So the first is what we call linearity property. So linearity, if we have two functions, f and g, so given two functions, f of t and g of t, and an arbitrary constant k, then one, the Fourier transform of f of t plus g of t. Who can guess the answer to this? What do you think will be the Fourier transform of sum of two functions?
It's the Fourier transform of f of t plus the Fourier transform of g of t.
Correct. So Fourier transform of f of t plus Fourier transform of g of t. But this is what gives me energy to do this teaching, because once people understand one concept, they are able to relate it to another concept and get it right. So that is what makes me happy dealing with such a group. And then what do you think will be the Fourier transform of a constant k multiplied by a function f of t?
K times the Fourier transform of f of t.
Correct. K times Fourier transform of f of t. And what do you think will be the Fourier transform of a constant a multiplied by f of t plus a constant b multiplied by g of t? How do you think that will give us?
A times the Fourier transform of f of t plus b times the Fourier transform of g of t.
Correct. So if you have such a class, you need not to be worried. And I believe you can actually carry this, you can actually confirm these relationships. You can easily prove this the way we prove the case for Laplace transform. Just from definition, you should be able to prove this. Can I trust that with you? Can you be trusted with the proof?
Yes.
Yeah. So just from the definition of the Fourier transform, you can always show that the left-hand side and right-hand side of these three equations are the same. So that because all these three are satisfied, so we can say that f is a linear operator. So therefore, the Fourier transform operator f is linear. So we say an operator is linear if you apply that operator to some of two functions, you get some of the operator on the two respective functions. And also, if you apply that operator to a constant times a function, you get that constant times that operator operated on the function. So as a quick example, find the Fourier transform of u of t e raised to power negative t plus u of t multiplied by e raised to power negative 2t. So this is how we solve this. So we'll say the Fourier transform of u of t, remember u is the unit step function, e raised to power minus t plus u of t e raised to power minus 2 is the same as the Fourier transform of u of t e raised to power minus t plus the Fourier transform this by definition of the first linearity property of the operator f. And as usual, I know this is a reliable group. We shouldn't struggle on the first part. What was the value in this case? The Fourier transform of u of t e raised to power minus t. The answer is
1 over I omega plus 1.
correct. So this is from the appetizer one. So we had already calculated that. So we need not to redo the computation. But remember, in an exam setup, you have to show the steps on how that answer was obtained. And then so the key thing will just now to evaluate u of t e raised to power minus 2t, which by definition will be the integral from minus infinity to positive infinity u of t e power minus 2t times e raised to power minus I omega t dt. This by definition of Fourier transform of f of t. But where do we carry out the integration from? Must we start from minus infinity?
We start from 0 to infinity.
Yes, 0 to infinity, because we know that for the unit step function, anything from minus infinity to 0 is given by 0. So carrying out integration from minus infinity is the same as sum from minus infinity to 0, then 0 to infinity, but minus infinity to 0, f of t is 0, so the integral is 0. So this is just integral from 0 to infinity. Now u of t will be 1, so we'll have e raised power negative 2t times e raised power negative I omega t dt. Since f of t equals to 0 in the interval minus infinity to 0. So this is, so we can write this as the integral from 0 to infinity. You put a negative and then 2 plus omega I or I omega t dt. The reason as to why we want a negative in the power of e is because we will be interpreting limit as t approaches infinity. And when we have the denominator having the exponential term, that becomes an easy expression to evaluate. So what would be the value of this integral. So t from 0 to t equals to infinity.
-2 plus omega I e power -2 plus omega it.
Correct. So negative into 2 plus I omega, or simply omega I. So I can pull out -1/2 plus I omega. And then I write 1/e raised power 2 plus I omega t from 0 to t equals to infinity. So when t is very large, what is the value of the exponential?
Zero.
So the
Infinity.
exponential will be a bigger number, then 1/big number is 0. Correct. And then when t is 0,
1.
1, because we'll have e power 0, which is 1, 1/1 is 1. So 0 minus 1 is -1, and this negative we get +1. So we have 1/2 plus I omega. So which means that the Fourier transform of EU of t times e power minus t plus u of t e power minus 2t. The first part was 1/1 plus omega I. Second part we have gotten 2 plus 1/2 plus omega I, and confirm that when you put all this as one fraction, you'll get 2 minus omega squared plus 3I omega, but then 3 plus 2I omega. So this will be the final answer to this problem. So just the same way we interpret the linearity in Laplace transform is the same way we do for Laplace transforms. For the Fourier transforms. Now, in similar manner, I want to trust you with the shift properties, check the shift properties, and then also do some examples on that. And then also check the relationship between the Laplace transform and the Fourier transform. I know your strength, and I know that can make sense to you. So it's so as I was telling you, the previous last week we didn't meet because we were chasing our payments. So it really took some time for us to reach the high offices and have a discussion with them, but by bad luck, things didn't work. So we are still chasing our payments. So sometimes when you see us missing some classes or starting classes late, it's not out of our making. So we try as much as possible to do what we have to do, but the top management sometimes do not, maybe they say they do not value part-timers. But what gives me energy to continue is for you to learn and make progress. I know when you make progress, I'll be building the nation. So for the last 2-3 years, we are not receiving anything. So sometimes even doing these classes, it requires a lot of, I don't know how I can describe it. But please, those who are in CU, please pray for us. Because we are going hard times. So the only thing you can make me, that can give me energy is for you to work hard and so that you pass and move to the next level. Probably things will be better for us through you. So try as much as possible to do your best. When sometimes I ask you to do some assignments and asking you to get the answers on your own, sending you handouts and sometimes videos, is not my wish. It's really not my wish. Sometimes I'm forced to do so, but I'm still repeat that the only thing you can, the only thing that motivates me is to see you progressing. So we have been together for 3 years. So I'm hoping that in 2 years' time, I'll be a proud person to say, at least in one way or another, I contributed to your success of being a full engineer. So please do your best. When I see people 25 over 30 in the cuts, people scoring 26 out of 30 in the cuts, people scoring above 21 in cuts, that is what motivates me. That's really what motivates me. So I really encourage you to work hard. Sometimes I'm sorry, I may be asking you to do much, but it's not my wish because sometimes I'm actually constrained to be in class. But the energy I get or what motivates me to even come to class, yet for the last, say, 2 to 3 years, I haven't been paid, is to ensure that you actually succeed. So please, let's help each other and try as much as possible to do the correct thing. Now, being in third year, you are required to be a little bit extra serious so that you don't find yourself in trouble with the exam office. So do your best, pass and then move to the next level without having issues with the department or any other thing in the school. But I still repeat, please pray for us. Is there any CU member in the class? Any CU member in the class? Vincent? Wangui, are you part of the CU crew?
No.
Yeah, but probably you know how to pray.
Yes.
Okay. Yeah, please pray for us. So the only thing that you can make me proud to even strain to wake up early and come to school to teach is for you to perform well. If you perform well, then that will be a worth sacrifice. So I request you. So if when I share the recordings, please try to check them, and things which are not okay, feel free to ask. Feel free to ask things which may not be clear to you when you are reading the handouts, when you are sometimes watching videos. Be open and ask, so that we can always help you to understand. So it is not my making. If things were running smoothly, I think I'll be doing all the 2 sessions per week. But I can't do that, because if I do that, I'll not be able to survive. So I have to forego 1 lesson to see how I can pay my bills. So please pray for us. And it's my request, please, you can watch my videos, you can subscribe, so that probably maybe I can get something from there. That's the only way, and you working hard. So let's meet next week, and please work hard, pray for us, and the work continues. So have a good day.